It is more than a simple entry in a ship's log. It is the last dispatch from the abyss. A yellowed page pulled from a dusty maritime archive. The log of the oil tanker SS Malmö, year 1966. The location? The Atlantic Ocean, somewhere along the 40th parallels. The captain's entry is dry, professional. It states they encountered a wave of anomalous height. The impact struck the bow. The bridge, standing 18 meters above the waterline, was completely inundated. The report concludes, damage insignificant, course unchanged. But the bridge was at the height of a 6-story building. What wave, born of wind and water, could rise to such a height in the open ocean? As an exaggeration, an error of the observer. Because according to the science of the time, such waves simply could not exist. Physics said it was impossible. Mathematics said it was impossible. Common sense said it was impossible. But what if the truth lay with the terrified sailors, not the esteemed scientists in the quiet of their studies? What if the ocean hides something that does not fit our formulas? Something primal, monstrous, and absolutely real. This investigation begins not with the question of what, but of why. Why, for centuries, did science refuse to believe the eyewitnesses? And what price did humanity pay for this academic hubris? The answer lies on the ocean floor, beside the wreckage of a ship once deemed unsinkable. A ship that set off on its final voyage, unaware it had a rendezvous with the impossible. December 7th, 1978. The port of Bremerhaven, Germany. The cold December air is thick with the smell of diesel and salt. At the pier stands the pride of the German merchant fleet, the container vessel MS München. This is no ordinary ship. It is a floating fortress, a marvel of late 70s engineering. 261 meters in length, nearly 3 football fields, a displacement of more than 50,000 tons. It is equipped with the most advanced navigation system of its era, immensely powerful engines, and a unique design. It is a lash carrier, an acronym for lighter aboard ship. It does not carry conventional containers. It carries 83 enormous floating barges on its deck, each weighing 370 tons. These barges are deployed by a gigantic 510-ton gantry crane that travels on rails along the entire length of the deck. The system allows the München to unload in any port, even those unequipped for modern container ships. The MS München is considered virtually unsinkable. Its hull is divided into numerous watertight compartments, a testament to a belief in its own invincibility. It was a vessel engineered to survive the unthinkable. Even with a catastrophic breach in its hull, it was designed to stay afloat. Its bridge towered 20 meters above the waterline, a steel citadel from which its crew surveyed the world. It seemed no conceivable wave, no force of nature could inflict a mortal wound. A crew of 28 souls, all seasoned mariners for whom the North Atlantic crossing was mere routine. This was the 62nd voyage of the MS München along this very route. She was bound for Savannah, Georgia. No one, on board or ashore, harbored any doubt that in 11 days she would arrive safely at her destination. They were wrong. The MS München would never again see a port. The ship sails into the open ocean, and almost immediately into the teeth of a storm. But this is no ordinary tempest. Since November, a cyclone of the century has been churning the North Atlantic into a frenzy. Hurricane-force winds, waves cresting at 15 meters. For any other ship, it would be a fight for survival. But the München was built for this. She holds her course with confidence, slicing through the maelstrom. Communication with her owners remains regular. All systems are nominal. December 12th, 3 o'clock in the morning. A whisper crackles across the airwaves. A faint, intermittent SOS, tapped out in Morse code. It is picked up by a Greek freighter, the Marian. The signal is from the München. The radio operator can only decipher fragments. SOS. 28 souls. Then, silence. A profound and absolute silence. The colossal ship, equipped with multiple independent communication systems, has simply vanished from the air. What follows is one of the most extensive search and rescue operations in peacetime history. The Coast Guards of the United States, Great Britain, Germany, and other nations scramble aircraft and dispatch ships. More than 100 vessels and 16 aircraft begin to comb the icy, raging Atlantic, square by agonizing square. They search for the ship, for the crew, for any trace at all. They find only the vast, indifferent emptiness of the sea. Hope erodes with every passing hour. Then, on December 14th, a search plane spots it. A lone life raft tossed upon the waves. It is empty. But the most terrifying aspect of the discovery is not the absence of life, but the evidence of how the raft was torn from its mothership. On the München, these rafts were secured in recessed bays, 20 meters above the waterline. They were fastened with heavy steel bolts, designed to be released manually. This raft had not been released. Its moorings had been ripped away with savage force, as if a colossal, unseen hand had plucked it from the deck and hurled it into the ocean. Marine engineers, later studying photographs of the wreckage, would conclude that to tear the raft free would require a force many times greater than any storm wave known to science could possibly generate. It was the first chilling clue that what happened to the München was something beyond all comprehension. Of the ship's cargo lighters, all are empty. Not a single body, not one life jacket. On December 20th, after 8 days of fruitless searching, the operation is called off. The sea offers no more clues, no final answers. It simply swallows the ship and her crew whole, leaving behind only a few pieces of impossible wreckage and a silence that echoes with questions. In the eternal contest between human ingenuity and the raw power of the planet, the ocean sometimes offers a brutal reminder of where the true dominion lies. The MS München and her crew of 28 are declared missing, presumed lost to the sea. In Hamburg, the Maritime Board launches its investigation. The experts sift through every possibility. An explosion? The München carried no volatile cargo. A collision? The shipping lanes were empty, the vessel alone in the vastness. A structural defect? She was nearly new, built to the highest standards of German engineering. Human error? Her crew were veterans, men who knew the unforgiving moods of the North Atlantic. The official conclusion, published 1 year later, is a masterpiece of frustrating ambiguity. The vessel, it states, was lost to severe weather conditions, which led to an event causing a rapid loss of buoyancy. An event. An unknown, unprovable event. The investigation had reached a dead end. The case was closed. But in the world of sailors, in the hushed quiet of port taverns, and on the lonely watch of captains' bridges, another story was told in whispers. A version of events that scientists and engineers dismissed as madness, the stuff of sea shanties. They spoke of killer waves, of sheer walls of water, sudden, monstrous swells that erupted from nowhere, capable of breaking the back of the largest supertanker. For centuries, these accounts had been filed away with folklore, tales of krakens and sea serpents. But the disappearance of the München and the chilling detail of a life raft found with its fittings torn from the ship's superstructure forced a reconsideration. It suggested a force of unimaginable violence. What if the monster was real? To understand just how revolutionary, how heretical this thought was, one must delve into the science of the ocean as it stood in the 20th century. Oceanography was a discipline built on the bedrock of statistics and mathematical models, frameworks that described the sea as a relatively predictable system. The dominant theory was the linear model. It viewed waves as harmonious oscillations could combine, their energies adding and subtracting, but the process obeyed the rigid laws of a Gaussian distribution. This meant the vast majority of waves were of an average height. Large waves were rare. Giant, extreme waves were a statistical impossibility. The mathematics were clear. A wave twice the significant height of the surrounding sea, a so-called rogue wave, should occur only once in every 300,000 waves. A wave 3 times as high? An event expected to occur perhaps once every 10,000 years. Based on these calculations, scientists had established a theoretical limit, a ceiling on nature's fury, approximately 15 meters. Anything higher was deemed impossible. And so, when sailors returned from the abyss, their faces etched with terror, speaking of 30-meter liquid mountains that rose from a flat sea, the men of science would listen patiently, and then they would simply shake their heads. Their models had tamed the ocean on paper, leaving no room for the monsters that haunted the minds of those who had actually seen them. They were explained away as tricks of the light, phantoms born of stress and the refracting haze of a storm. In the ordered world of mathematics, a world of clean formulas and predictable graphs, there was simply no space for monsters. The ocean, they were certain, was a linear system, and they were profoundly mistaken. The testimony continued to accumulate. These were not the tall tales of superstitious sailors, but the formal reports of captains and officers, men of impeccable reputation. In 1933, the American naval tanker USS Ramapo, caught in a Pacific storm, measured a wave with its onboard instruments. Its height, 34 meters. The report was so incredible, it was quietly filed away, buried by disbelief. In 1966, the Italian liner SS Michelangelo, en route to New York, was struck without warning by a colossal wave. It tore through the superstructure 24 meters above the waterline, killing 3 people and injuring dozens. Survivors described it not as a wave, but as a vertical wall of water. In 1975, on the vast expanse of Lake Superior, the bulk carrier SS Edmund Fitzgerald vanished without a trace during a storm, taking its entire crew with it. The captain's last transmission was calm. "We are holding our own." Then, only silence. One theory holds that it was overwhelmed by the so-called Three Sisters, a series of 3 abnormally large waves known to plague the Great Lakes. Each incident was dismissed as an anomaly, an outlier that official science sought to explain with any available variable. Resonance, interactions with deep sea currents, anything but the admission that their fundamental model of the ocean could be wrong. The loss of the cargo ship MS München in 1978 would be the breaking point. The loss was too great, the vessel too modern, and a single piece of evidence recovered from the wreckage was too inexplicable. A lifeboat, torn from its davits 20 meters above the water by a force that defied all calculation. Within the scientific community, a quiet rebellion began to stir. A few young, audacious oceanographers started asking uncomfortable questions. They proposed that the ocean was not a linear, predictable system, but a complex, non-linear one. And in such systems, as physics had long known, extreme, catastrophic events were not just possible, they were inevitable. They theorized that waves could do more than simply add together. They could steal energy from one another, concentrating the power of many into a single, monstrous crest. The idea was met with fierce resistance. It demanded a complete revision of the foundations of oceanography. What they needed was proof. Irrefutable, instrumental proof. They needed a photograph of the monster. That photograph would be taken 17 years later, on the first day of 1995. The Norwegian North Sea. It is one of the most inhospitable bodies of water on the planet. Here, in the Draupner gas field, stands the oil platform of the same name, a gargantuan structure of steel and concrete, anchored to the seabed, engineered to survive the most brutal storms imaginable. A hurricane is raging. Winds reach speeds of over 100 kilometers per hour. The average wave height is nearly 12 meters. For the platform, it is a severe but manageable assault. On board the Draupner platform, a skeleton crew keeps watch over a restless sea. No one expects the day to be anything other than routine. The structure is a fortress of modern engineering, bristling with the most advanced measurement equipment of its time. Among its instruments, a high-precision laser rangefinder, aimed vertically at the waves below, continuously maps the profile of the ocean's surface. Its data streams silently to a computer, another routine entry in an endless ledger of marine statistics. Then, at 3:20 in the afternoon, local time, an event occurs that will forever be etched into the annals of science. The laser rangefinder detects the approach of a solitary, impossibly steep wave. It seems to materialize from nowhere. The computer, dispassionate and precise, logs its parameters. A height, from trough to crest, of 25.6 meters. The vertical face of a 9-story building, rising from the sea. It is more than double the height of the significant waves surrounding it. A perfect, textbook definition of a monster. With a deafening roar, the wave strikes the platform. The entire structure shudders, but it holds. The personnel on board are startled, but unharmed, not yet realizing what they have just witnessed. But in the quiet of a laboratory, stored on a hard drive, is the irrefutable proof. When the data is finally analyzed, the scientific world is shaken. Here is the smoking gun they had long sought. No longer could the stories be dismissed as the exaggerations of sailors. No longer could science hide behind the safety of its linear models. The Draupner wave, as it came to be known, was the first instrumentally verified rogue wave in history. It proved they were real, and it proved they could erupt far from powerful currents, in the deep, open ocean, born from nothing more than the internal dynamics of the wave field itself. The discovery was a turning point. It forced physicists and oceanographers to completely reevaluate their understanding of the sea. It became terrifyingly clear that the linear models, which worked so well for describing the vast majority of waves, failed catastrophically when confronted with the extreme. The ocean was not a predictable system. It was non-linear. A frantic search for new models began. Scientists turned to equations once confined to the realms of quantum meomplex mathematics. They found a phenomenon known as modulational instability. Put simply, it is a process where a uniform train of waves can spontaneously destabilize. Energy from adjacent waves begins to funnel into a single central wave. It grows at their expense, feeding on their power, becoming a short-lived but monstrous peak. It is as if in a vast crowd marching in perfect unison, one person suddenly begins to leap, drawing strength and momentum from all those nearby, soaring impossibly high for one fleeting moment. The Draupner wave had opened a Pandora's box. Scientists scrambled to re-examine decades of old data from buoys and satellites, hunting for the ghosts of monsters they had previously missed. One wave on one day had rewritten the laws of the ocean. It revealed that the calm, predictable surface we think we know is merely a mask, hiding a potential for sudden, chaotic violence that we are only just beginning to comprehend. They began to find the signatures of rogue waves everywhere. The European Space Agency launched a project codenamed MaxWave. Analyzing just 3 weeks of satellite imagery of the ocean's surface, they identified more than 10 rogue waves, each towering over 25 meters high. It became terrifyingly clear. These were not rare events, not a 1 in 10,000 year anomaly. They were happening constantly, across all the world's oceans. With this new, frightening picture of reality, many old mysteries began to find their explanation. Chief among them was the riddle of the cargo ship MS München. Armed with a new understanding of nonlinear wave physics, investigators and maritime experts looked again at the tragedy. Suddenly, all the pieces of the puzzle fell into place. The strange clues. First, the sudden and complete cessation of all communication. Second, the absence of any coherent message describing the nature of the distress. Third, the lifeboat, torn from its mountings 20 meters above the waterline. Fourth, the relatively small amount of wreckage ever found. Now imagine a new scenario, one born from a collision with a killer wave. The München is forging through 15-meter storm waves. For the crew on the bridge, this is a familiar violence. And then, dead ahead, a wall of water rises from the roaring darkness. It is not a sloping hill, but an almost vertical precipice of the sea. Its height is 30, maybe 35 meters. They have no time to react. They have no time even to comprehend what they are seeing. The impact strikes the bow. Millions of tons of water collapse onto the deck. But it is not just an impact. It is something far worse. As the ship plows its nose into the base of such a wave, its stern is lifted high into the air. Then, as the crest passes underneath, the bow is thrown skyward, and a void, a chasm of air, opens beneath the central hull. For a single, horrifying moment, the giant ship is supported by only 2 points, the crests of 2 adjacent waves. Its own colossal mass and the weight of its cargo becomes its executioner. The metal cannot withstand the strain. With a deafening crack, the hull breaks in half. Simultaneously, the crest of the wave smashes over the bridge. The concussive force shatters the windows, annihilating all navigation and communication equipment. It almost certainly kills everyone on watch, instantly. This explains the sudden silence. It is this same impact, crashing down upon the ship from above, that explains the mystery of the lifeboat. The wave, washing across the deck at a height of 20 to 25 meters, simply scoured clean everything in its path, tearing the ill-fated boat from its steel fastenings. The ship, broken in two, sinks in a matter of minutes. The crew has no chance to launch lifeboats or to transmit a meaningful distress signal. The catastrophe was sudden, total, and irreversible. This version of events, a theory which only 20 years ago a logical explanation, the monsters of sailors' folklore were not myth. They were a brutal reality, waiting in the dark for a science that could finally see them. It resolves the lingering questions surrounding the loss of the MS München. It transforms a baffling disappearance into a tragic yet comprehensible testament to the power of the open ocean. At long last, the monster that dragged the München to the depths was given a name: nonlinear fluid dynamics. The mystery was solved. But the story does not end there. It is only beginning. Because now, we know the monsters are real. And they do not hunt only in the North Atlantic. They stalk the coast of South Africa at the Cape of Good Hope. For centuries, mariners have called this place the graveyard of ships. Here, the waters of the Atlantic and Indian Oceans collide. The mighty Agulhas current, flowing against the prevailing westerly winds, creates the perfect crucible for the birth of rogue waves. Sailors who have survived these waters speak not of walls of water, but of holes in the ocean. A colossal trough suddenly yawns open before a vessel, followed by an even more colossal crest. The ship plummets into the abyss, only for the subsequent wave to 20th century alone. More than 100 vessels were lost in this region. They are found even in the Great Lakes of North America. Seemingly placid freshwater bodies, their immense scale and unique hydrology give rise to their own variant of the killer wave, the infamous Three Sisters. It is a sequence of 3 abnormally high waves rolling in one after the other. The first wave swamps the deck, adding immense weight to the vessel. The second strikes before it can recover, hitting with even greater force. The third, the last, delivers the final, crushing blow. It is this terrifying phenomenon that is believed to have claimed the freighter Edmund Fitzgerald in 1975. Even modern cruise liners, these floating cities, are not immune. In 2005, the Norwegian Dawn, with 2,000 passengers aboard, was struck without warning by a 21-meter wave. It shattered windows on the 10th deck, flooded 62 cabins, and injured several people. Fortunately, there were no fatalities. But the incident was a stark reminder that even our most advanced vessels remain vulnerable. Sometimes these monsters breach the shore. In 1991, on Daytona Beach, Florida, under a perfectly clear and windless sky, a 6-meter wall of water, 43 kilometers long, crashed onto the sand. It swept away 100 automobiles and injured 75 people. To this day, scientists cannot fully explain its origin. It was not a tsunami. No seismic activity had been recorded. Perhaps it was the result of a complex, long-distance resonance of ocean swells. The mystery endures. Today, the primary challenge is not to prove that rogue waves exist, but to learn how to predict them. It is a task of staggering difficulty. A rogue wave is a local, fleeting event. It can materialize in as little as 10 to 15 seconds. Existing forecasting systems can only highlight broad regions of the ocean where the probability of their formation is higher. We have given the phenomenon a name. We have measured its terrible power. We have charted the waters where these leviathans are born. Yet for all our knowledge, we can only stand and watch. The ocean guards its darkest secrets, reminding us that in a world we seek to control, there are still forces that defy prediction, emerging from the depths without warning and with absolute indifference. To give a precise, timely forecast for a specific ship, however, remains beyond their grasp. A new generation of radar systems is now in development, a technological gambit designed to scan the surrounding ocean surface. By analyzing the chaotic tapestry of the wave field, These systems could predict the birth of a liquid monster mere minutes before it strikes. That narrow window of time would be enough. Enough for a captain to alter course, to reduce speed, and to meet the oncoming wall of water bow on. A maneuver that dramatically increases the odds of survival. It is a race against the inevitable, a contest between human ingenuity and the primeval, indifferent chaos of the sea. The saga of the MS München and the validation of the Draupner wave is more than a maritime drama. It is a profound parable on the very nature of human knowledge. It reveals how our most elegant scientific models, built over generations, can shatter against the brute force of reality. It teaches us humility. It teaches us to listen to the voices of those who were there, in the epicenter of the storm, who witnessed what the quiet certainty of our laboratories had deemed impossible. It is a stark reminder that forces exist in the natural world that still dwarf our understanding and mock our technology. And so, we are left with the final, unsettling questions. If science could be so profoundly mistaken about the ocean for centuries, what other certainties of our modern world are merely illusions, waiting to be broken? Which of the ancient mariners' tales, long dismissed as myth, are in fact harrowing truths yet to be rediscovered? And how we learn to grant the proper respect to the power that covers 2/3 of our world. The ocean keeps its secrets well, and it does not suffer being underestimated.